Hello students, welcome to Excellence Batch. I hope you have already seen all the lectures of differential equation and now it has been clear that okay, you can score full out of full marks from that chapter, whether it is board or it is any competitive exam. I've shown you in the last lecture that how in PYQ means in previous year questions, how they have given from similar variety of questions and you can easily do that. Means they are simple. Maybe some questions were lengthy, but they were simple. The algorithm, the procedure was simple. Now, today we are going to discuss about one very small topic which is termed as linear programming. Linear programming, this is only because this is only based on board exams. Means in your board exams this is a must because one question will come from this chapter anyways. Okay, but in JEE mains there is no thing that okay question will come from this part. It has been not given in any of the exams. One question was there in 2021 which was supposed to be solved by LPP, but no. The NTA, what the key they have released, they used maximum minimum method. I will discuss that question also with you. So it's a very simple chapter. Moreover, CBSE have reduced all the application part of LPP. Application means manufacturing problem, diet problems, all those transportation problem, all those application has been removed. Okay, only simple equations, and there are 3 cases. Each one of those cases I will discuss, which is with those things that will be making sure that you will get full out of full marks from this chapter in your board exams, at least. Okay, so let's get started. So first of all, let's discuss about linear equations, sir. What I mean by linear inequations. So linear equation in 2 variables, the inequalities of the form ax plus by less than c or less than c, greater than equals to c or greater than c. These are termed as linear inequations. Equations are where you have only equals to. A straight line equation, you can say ax plus by plus c equals to 0. These are equations. Now if you put an inequality, that will become inequations. Are called linear equations, inequations in 2 variables x and y. The point x comma y for which the inequation is true constitute its solution set. So now it's an inequality, so instead of one point there will be many points. There will be many points in the coordinate system which will be satisfying this inequation. Okay, so the set of all such points which will satisfy this will be termed as the solution set. So it will be huge, sir. It will be huge. So first of all, instead of jumping directly to LPP, first of all we will learn. I will teach you how to plot the region which is the solution set of these equations. Okay. So how to proceed in this? Let us consider an inequation. Suppose an inequation will be given. For drawing its graph, to obtain a solution set, we proceed as under. I have given everything in notes form so that you can go through it in a very short and precise way. Step 1. Consider the equation. Means to plot this inequation, we remove inequality and we take it as a standard equation, linear equation. So it will become a straight line. So you can plot a straight line. It is very simple to plot any straight line. How? Put x equals to 0, you will get y equals to something. Put y equals to 0, you will get x equals to something. So I'll get 2 points. Now, from 2 points, only one straight line can pass. From 2 points, only one straight line can pass. And plot the resulting line. In case of strict inequalities, draw the line as dotted, otherwise mark it as a thick. Because if only greater than or less than is there, that means you cannot take points on the line. If it is greater than or equals or less than or equals, that means you can take points on the line also. So that's why. So if equals to sign is not there, you can make it as a dotted line or else make a thick line. Means now step 2. Choose a point. Means now after drawing a equation means of a straight line, you will get 2 regions. So take any point from any of the region. Now substitute this coordinates in the inequation. If the inequation is satisfied, then shade that portion of the plane which contains the chosen point. A straight line, if you have learned straight lines, you already know that a straight line divides the coordinate into two parts. So if one of them satisfies the inequation, that entire plane will be your solution. If that point will not satisfy, that means the opposite side will satisfy your equation, means your plane. That's it. Very simple. Now, the shaded portion represents the solution set. The dotted line is not a part of the shaded region, while the thick is a part of it. That I have already make you understood that if equals to will be there, then the thick line, the line and the plane, means the shaded part, will be your solution. But if it is only greater than or less than, means without equals to, then the dotted part will not be the solution, only the shaded part will be the solution. Okay. Now, the solution set of system of linear inequation in two variable is a set of all points which satisfy all the inequation in the system simultaneously. So, sir, that was thing about only one equation. We draw the line, we shaded the region. But if there are suppose more than one, there are two equations, three inequations, or four inequations. So, the common of all such parts will be your solution set. So we find the region of the plane common to all the portion. That is what I've told you. You need to find the common to all the portion comprising the solution set of the given inequations. When there is no region common, now note this, when there is no region common of the given inequation, we say that the set of the system is empty, that the solution set is empty. The linear inequations are also known as linear constraints. So for LPP, these linear inequations will be termed as linear constraints. This will be termed as linear constraints. So before going to LPP, first of all, I need to make sure that students are able to answer these shade the parts, and they are able to make it the solution set of simultaneous inequations. Okay. So first let's not more, one or two, because all questions are of same time. If you understand one, you can automatically do the second and third and fourth and all. So very limited, very precise, short and crisp I have kept this chapter so that your time will not be wasted much. Okay. Now, like this is the question, sir. Draw the graph of the solution set of the system of equation 2x plus 3y greater than 6, x plus 4y less than 4, and x greater than 0, y greater than 0. Now, first of all, I have kept a different page. No. So, if this is your system, x greater than 0, y greater than 0, both positive means first quadrant, means I need answer in first quadrant. These two meaning is you need answer in first quadrant. Understood? So there are basically four inequalities. And see, it is equals to 0. That means the x and y axes are included. Now, coming to the line. One line is 2x plus 3y equals to 6. And one line is x plus 4y equals to 4. I have explained you, first of all, make it as a equals to, get a equation of the straight line so that you can plot it. Now, since less than or greater than equals to is also there, so the thick line will also be part of your solution. Now, how to draw this line? Put x is equals to 0. So, y will be 6 by 3, 2. Put y equals to 0, x will be 6 by 2, 3. So, I got 2 points, 0, 2 and 3, 0. One by one. I'm not saying that simultaneously you are jumping to all the things. One by one. First of all, I'm drawing the first line. Sir, one point is 2, 0. Let this be 0, 2. One point is 3, 0. Let this be 3, 0. Now, extend this. This is your line. This is your first line. But I need greater than 6. You need 2x plus 3y greater than 6. Now, put any point. Always preferable, put 0, 0. Because now there are two regions, sir. This is one region, this is one region. So I'll take 1 point, 0, 0. Sir, 0 is greater than 6? No. That means this region is your not answer. Above region will be your answer. Mark it like this. Above region will be your answer. You can mark with a pencil or something in board exams like small arrows or dot. Okay. So first line is done. Now what about the second, sir? When you put x is equals to 0, y is 1. When y equals to 0, x is 4. So sir, the points are 0, 1 and 4, 0. So obviously they will intersect, but to be sure, you need to solve these two equations and find the intersection point. Sir, one line is 2x plus 3y is equals to 6. Multiply by 2. So 2x plus 2 4s are 8y equals to 8. Minus 5y minus 2. Minus 2. So plus. So y will become 2 by 5. Y will become 2 by 5. Now you can substitute this y value in any one of the equation. So x will be 4 minus 4y. So 8 by 5, 5 4s are 20. 20 minus 8. So 20 minus 8 is 12 by 5. So x will become 12 by 5. Now, if you draw this line like this, so 12 by 5 is 2 point something. So they are intersecting at certain point. Now the second line is x plus 4y less than 4. Okay, substitute 0, 0. Sir, 0, 0. 0 is less than 4? Yes, sir. So that means my answer will be below of this line. My answer will be below of this line. Now you tell me, sir, which is the common part? Which is the common part above of this line, below of this line? So basically this entire line, but I need in first quadrant. But I need in first quadrant. So that means only this triangle is your answer. So shade that part. Only this triangle will be the answer. Because then other region which is common is after, means this region is not acquired by the line because I need above the line but below this line. So this yellow part, this yellow shaded part is your answer, like this, like this. So in LPP also same things will come, same line equations will come. You need to find the, means what you can say, the common solution. And always after finding common solution, you should know the, if it is a closed diagram, you should know the corner points like 3, 0, 4, 0. What is this corner point? This corner point is, sir, 12, 5, 2 by 5. Like this. This is the way of plotting a or simultaneous inequation, solving simultaneous inequation. One by one. I draw one line, I draw second line, automatically you will get the answer. Automatically you will get the answer. Like this, sir. In this way, you draw the things. Okay. I hope it's clear. Let's solve one more question to understand more. Like here, sir. One line, two line, y less than 5, x less than 6, x greater than 0, y greater than 0. 6. In total, 6. So again, sir, this is first quadrant. That means you need things in first quadrant only. You need things in first quadrant only. Okay, so these two parts done. These two parts done. Now, this x less than 6. Okay, sir, before x less than 6, let's talk about these two lines. First one, x plus y equals to 1. 7x plus 9y equals to 63. This is the thing, sir. Okay. So clearly, sir, 0, 1 and 1, 0 if you put. So it's this line, means suppose this is 0 comma 1, this is 1 comma 0, or little bit this side. Okay. But I need what? X plus y greater than 1. So put 0 comma 0. So I will get 0 greater than 1. Is it possible, sir? 0 can be greater than 1? No. So that means my answer is above this. Above this. Okay. One line done. Next. 7x plus 9y. So when x is 0, y is 63 by 9 is 7, sir. 63 by 9 is 7. Then if y equals to 0, x will be 63 by 7 is 9. So, sir, 0 comma 7, and then you can say what? 9 comma 0. So you need to see whether they are intersecting in first quadrant or not. How, sir? Solve them, sir. Nothing else. And also here I need 7x plus 9y less than 63. So if you put 0, 0, 0 is less than 63. So that means below side. Okay. So, sir, 7x plus 7y equals to 7. 7x plus 9y equals to 63. I am solving and seeing where they will cut. So minus 2y. This one will be 63 minus 7 is 3 and 4, 56. So y will be 28. So if you put 28, so x value will be minus 27. X will be minus 27. So that means they will intersect in second quadrant. They will intersect in second quadrant, not in first quadrant. Not in first quadrant. So easily you can draw this line like this, and the answer is below these lines. Okay. But still work is not over. Still work is not over. Now the next is y should be less than 5. Sir, 5 will be somewhere coming here. Okay. 0 comma 5. So y less than 5 means below. If it is greater than 5 means up, less than 5 means below. Means this part, right? You can see that this is the common part which is coming. Next is x should be lesser than 6. So if this is 9, somewhere here, sir, x or somewhere here, x equals to 6 will come like this. So obviously that will be this side. So this means this area. You can say this area is the common area which is common to all. Which is common to all. Like this. If it is 2, if it is 4, if it is 6, the method and procedure is same. After this, I have just told you to mark all the, what you can say, the corner point. Here 0 comma 1, here 0 comma 5. What about this, sir? In this, sir, y is 5. In this, y is 5. So put y equals to 5 here. So if you put y equals to 5, it will become 7x plus 9 5s are 45 equals to 63. So x is equals to 63 minus 45 by 7. So what it will become, sir? It will become 5, 50. So 5 plus 13. So 5 plus 13, 18 by 7. It will become 18 by 7. Okay, sir. It will become 18 by 7. This is 1 comma 0. This one will be 6 comma 0. Now only this point left. In this point also you need to put x equals to 6. You need to put x is equals to 6. So 7 6 are 42 plus 9y equals to 63. So y is equals to 63 minus 42 by 9. Sir, 63 means 8. So 8 plus 13, 21 by 9. So that is 3s are 7s are. So 7 by 3. Y will become 7 by 3. So 6 comma 7 by 3. Like this. This is now the complete solution. So in this way, sir, you need to solve the system of linear inequations. System of linear inequations. Okay. So in total, after now realizing the two parts, in total there can be three cases. This is termed as bounded. This is termed as bounded because it is bounded by the graphs from all over. Okay. One case when no region will be common, that will be termed as no region common, no solution at all. And third will be unbounded. Many a times the region will become unbounded. It will go up to infinity. So based on these three parts only LPP problems will be solved. Means what you need to do when it is bounded, when it is unbounded, when it is no solution. So one by one we need to see what in LPP. First of all, the first part is this only. You need to make the solution of the linear constraints. Okay, you need to make the solution of the linear constraint. I hope now that will be easier because you have already done these two questions. After that, based on the case, we need to learn one more step. Okay, that okay, if it is bounded, then what you need to do. If it is unbounded, then what you need to do. And the third part will be if it is not bounded, then what you need to do. Okay, so let's see one by one those questions. First of all, let's learn some terminologies based on linear programming. Some terminologies means something will be asked in exam. You should be able to understand what is the meaning of these terminologies. Like here, linear programming is the method used in decision making in businesses for obtaining the maximum or minimum value of a linear expression. Means sometimes they will calculate a linear expression for their system, for their business. So for what value of x or y or whatever variables we will take in that equation, what value of x and y we will get the maximum output or minimum cost, it depends. So basically the main motto should be to get the minimum or maximum. Okay, subject to satisfying certain given linear inequations. Subject to certain linear inequation. The linear expression is known as objective function. Means the thing which we need to minimize or maximize will be termed as objective function. Will be termed as objective function, and the linear inequations are known as linear constraints. And the linear inequations are known as linear constraints. Okay, are known as linear constraints. These are the two things which you need to understand. Now, some more terminologies are there, like here. Linear constraints, I have already told you. The linear inequations on which the things are based are termed as linear constraint. In business or industry, we want to make the best use of limited resources like money, labor, time, material, etc. So the limitations on the resources can often be expressed in the form of linear inequations, known as linear constraints. Known as linear constraints. Now, objective function. Objective function. The linear function of the involved variable which we want to maximize or minimize, that is termed as objective function. So there are two main things: objective function which we need to minimize or maximize, and the linear constraints which are there about which we need to find the minimum or maximum. Then optimal value of an objective function. So the maximum or minimum value of an objective function is known as its optimal value. So either maximum or minimum of the objective function is termed as optimal value. Is termed as optimal value. Now feasible solution. Now this is related to something simultaneous equation. The set of values of the variable satisfying all the constraint is known as feasible solution of the system of inequations. Like in the first two example, we got something common from all the equations, right? So that common part is termed as feasible solution. That common part is termed as feasible solution. Now, optimal solution. A feasible solution which leads to the optimal value of an objective function is known as optimal solution. Okay. Now, optimization techniques. The process of obtaining the optimal values of the system of inequations are called optimization techniques. So, the major thing is objective function, which we need to minimize or maximize. Linear constraints about which the entire business or the things are dependent. Third is optimal solution, which we are getting from feasible solution, Understood? So these are some terminologies which you need to understand, Okay. Now, how to solve LPP problems? A general linear programming problem consists of maximizing or minimizes an objective function subject to certain given linear constraint. Means in general problem, always there will be one objective function and some linear constraints. Now, formation of linear programming problems. Step 1, identify the unknown in the given LPP, denote them by X and Y. But this thing now have been deleted by the CBSE. Now they are giving only direct forms, means direct objective functions and linear constraint problems only. Now formulate the objective function in terms of X and Y. Be sure whether it is to be maximized or minimized. Third, translate all the constraint in the form of linear expressions, linear inequations. Okay. Then solve these inequations simultaneously, like we did solve in the first part. Mark the common area by a shaded region. This is the feasible region. Like I've told you, the shaded part or the common part from all the linear inequation will be termed as feasible region. Now find the coordinates of all the vertices of the feasible region. That's why there I've told you, wherever the vertices are becoming, the corner points are becoming, mark down all those vertices. Why? Find the value of the objective function at each vertex of the feasible region. It has been observed by the great mathematicians that in a particular LPP problem, if a feasible region is bounded, then the maximum or minimum values always occur on the vertices. Maximum or minimum values always occur at the vertices. So that's why we need to find the objective function value on the vertices. Okay. Then find the value of X and Y for which the objective function is maximum or minimum value as the case is asked. That's it. Means what we have done, first of all, we solved simultaneous equations. We got the feasible region. Now in the feasible region, you got the vertex points. Now get the objective function value on those points. So if you need maximum, so the maximum of all will be your maximum point and the minimum of all will be your minimum point. That's it. This is that. Means done. Nothing else to do in LPP. Easy 5 to 6 mark question will come from this part. Just you need to properly solve it. Now difficult part comes when the region is unbounded. If it is bounded and feasible, it's very simple. If it is unbounded, then one extra step you need to do, that is there. And if it is unbounded, then you say no solution. Means sorry, if there is no region at all, there is no feasible region at all, you will say no solution. So out of the three, the first and the last case are very simple. The middle case only will have one extra case. So one by one, I will show you all the three cases and things are done. Nothing more you need to do about this chapter. One question is more than enough because all questions are of same type. You can practice then three more questions at your home by your choice. Things will be done, sir. Okay. Now, so the maximum or minimum value of a linear function over a convex polygon occurs at some vertex of the polygon, like I've told you. So we look at the values of the objective function at the vertices of the set of feasible solution. The largest of these values is maximum and the smallest of these values is the minimum, like I've already told you. Means at the vertices we find the value of objective function. The largest of all will be maximum, the minimum, the smallest of all will be minimum. That's it. Nothing else. Okay. Moving to solve a question like here, sir. Solve the following problems graphically, minimize and maximize. So your objective function is z is equals to 3x plus 9y. Your objective function is z is equals to 3x plus 9y. So basically, I need to find this value of z and means what? I need what? Minimize and maximize I need to do. I need to find the points. So first of all, you need to solve 1, 2, x less than y, 3, 4, 5. 5 equations. I need to solve this 5 equation. So let's solve and get the vertices point and then talk about the LPP. Because the first part is solving simultaneous equations. And these are the linear constraint about it. Okay. Now, the same question, sir, I have copied in on the another slide. So what we need to do is, sir, first quadrant only, because these two things are saying first quadrant. Now, first of all, x plus 3y less than 60. So if you put x is equals to 0, y will be 20. Means if I put x is equals to 0, y will be 20. And if I put y equals to 0, x will be 60. So let's draw this line. So 60 comma 0. So 60 comma 0, and let this be what you can do 0 comma 20. Like this. Line will come like this. Now put 0 comma 0, sir. 0 is less than 60. So I need below this line. I need answer below this line. First line is done. Second, x plus y greater than 10. X is 0, y is 10, y is 0, x is 10. So sir, 10 comma 0, 0 comma 10. Like this. So obviously it will meet at some point in second quadrant. Now this much surety you need to do. Now put 0 comma 0, sir. 0 is greater than 10? No, sir. So I need opposite of this. This region will be my answer. Okay. Now, sir, apart from these two, there is one more line, x less than y. Now always remember, this is x is equals to y. Okay. So this line is your x is equals to y. But I need x less than y. Then how to, sir? Sir, take one point, na? Take 0 comma 10. 0 comma 10 is also a point, na? So 0 is less than 10. Yes, sir. 0 is less than 10. That means this is my answer or feasible region. This is my feasible region. So in first quadrant, below this, above this and this. So this, sir, this yellow part will be my feasible region, which is clearly bounded, right? Right, sir. Now, I need the corner points. Only one step left. I need the corner points. So I hope making equation and plotting, it's very simple, right? Now, corner points, sir. This point is 0 comma 20. This point is 0 comma 10. Now this point, you need to solve y equals to x with each of the equation. So sir, x plus 3y equals to 60. Put x is equals to y. So 4x is equals to 60. X is equals to 15. So that means this point will be what? If I put now x is equals to 15, then y will also be equals to 15. Y will also be equals to 15. So this point will be 15 comma 15. 4 ones are, yeah, 15 comma 50. Now, sorry, this point is 15 comma 15. Now this one is this point. So 2x is equals to 10, x is equals to 5. So this point is 5 comma 5. This point is 5 comma 5. Like this. So I got the 4 points, 0, 10, 0, 20, 5, 5, 15, 15. This is the process, sir. In this way, you draw your feasible region. In this way, you draw your feasible region. Now coming back. Sir, what all points you got? I got point as 0, 20, 0, 10, 5, 5, and 15, 15. You got these 4 points. Now get this objective function value on these points. Like 0, 20, sir, 9 zeros are 0, 9 twos are 180. 0 and 10, so it will be 90. Now 5 and 5, sir, 3 5s are 15, 9 5s are 45. So 60. And 15 and 15, 3 into 15 is 45, and 9 into 15 is 9 5s are 45, 4, 9 1s are 135. So 5 5 10, 5 plus 3 8, 180. So that means this is your maximum and this one will be your minimum. This one will be your minimum. So they will say, if there are two questions, if they ask maximum value, so the maximum value will come as 180. If they ask minimum value, the minimum value will be 60. If they ask at what point or what value of x and y they will attain, so they are attaining means maximum at 2 points and minimum at 1 point. And minimum at 1 point. I hope this is clear. So the first case is always simple. Why? Because this is directly variable, means what you can say feasible solution. So the vertices will only help you to get the answer. Understood? The first case, solving simultaneous equations. Okay. Neatly you can draw this on a graph paper in board exams. Easily you can plot this. Okay. Chalo. Moving to the next question. Now sir, determine graphically the minimum value of the objective function. They're asking minimum value of this subject to constraint of this. Subject to constraint of this. So minus 50x plus 20y. Now points I need to find out first of all. Right. First of all, I need to find out the points. 1, 2, 3. 3 lines are there this time. Okay. So let's find out the points. I've already kept in a separate slide. So sir, first is 2x minus y greater than minus 5. 3x plus y greater than 3 and 2x minus 3y less than 12. Okay, but I need in first quadrant only. I need in again first quadrant only. Now here sir, if x is 0, y will be 5. If y is 0, x will be minus 5 by 2. Okay, let somewhere here it is minus 5 by 2 and 5. This one is 0, 5. Like this, sir. Equation will be somewhat like this. Okay. Now, take 0, 0, sir. 0, 0. 0 is greater than minus 5? Yes. 0 is greater than minus 5. So I need in first quadrant, na? So forget about this. First quadrant. Now, coming to this part. Here, if x is 0, y is 3. If y is 0, x will be 1. So, 1, 0 and here 0, 3. So, obviously they are intersecting at where? Second quadrant only. So, no need to find that point. This point is what we have taken 0, 3. Okay. Now, put 0, 0, sir. 0 is greater than 3? No, sir. So, this above this will be your answer. Now, the third line. If I put x is equals to 0, y will be 12 by minus 3 minus 4. if I put y equals to 0, x will be 6. So sir, 6 comma 0, okay, 6 comma 0 and 0 comma minus 4 and 0 comma minus 4 somewhere here. So clearly we can see that they will intersect at somewhat other places, means either in fourth and first, means they are not intersecting in first quadrant at all. Sometimes just by diagram, because it is going from below, na sir. It is never going up only. So now put 0 comma 0, sir. Sir, 0, 0. 0 is less than 12. 0 is less than 12. That means up of this. Means up of this. Okay. So that means the common region, this point, this point, this point. Sir, the common region, you can say that it's this part. The common region is this part. I hope it's very clear. The common region is this part. Okay. Bright and clear. This is our common region. So it is unbounded, sir. This is the second case where I've told you it can come as unbounded. If it was bounded, then what you need to do is just find the value at the vertices. But it came unbounded. It came unbounded. But still I got some points, corner points. 0, 5, 0, 3, 1, 0 and 6, 0. So if bounded comes, this is that second case which I was telling about, that if unbounded comes, then what you need to do is you need to do one step extra. What is that one step? First of all, 1, 0, 6, 0 means 1, 0, 6, 0. What else point is there? 1, 0, 6, 0. So this is 1, 0 only, right? I think 0 comma 10. Oh, this is 10, 0 and sorry. Yeah, 1, 0, 6, 0, 0, 3 and 0, 5. 0, 3 and 0, 5. Find the value, sir. If I put 1 comma 0, I'll get minus 50. If I put 6 comma 0, minus 300. 0 comma 3, 60. 0 comma 5, 100. So that means at this point I am getting maximum, at this point I am getting minimum. Okay, I got the point. Now this is the value. Now what you need to do is, now you need to think, sir, it is minimum, right? Means the minimum what this can attain is minus 300. The minimum what this can attain is minus 300. So you will say that Z is greater than, means what you can say that Z minimum is minus 300. That means this implies that minus 50x plus 20y is greater than or equals to minus 300. Because it cannot go less than minus 300, na? So it will be always greater than or equals to minus 300. If suppose that was for maximum, there they are asking for minimum, so means the objective equation greater than the minimum value. If they would have asked maximum, then you must have written minus 50x plus 20y should be less than or equals to 100 if they would have asked for maximum. If they would have asked for maximum, this they had asked for minimum. So in that means Z always will be more than the minimum value. In that case, Z will always be lesser than the maximum value. Both question I'm telling you in the same question. Now what, sir? So this becomes one more equation to you. This becomes one more equation to you. Minus 50x plus 20y greater than 300. So come to this side. Minus 50x plus, sir, plus 20y plus 20y greater than equals to minus 300. So sir, 1 0 0 0 will get cancelled. It will become minus 5x plus 2y greater than or equals to minus 30. Now plot this line. You need to plot this line. Sir, if I put x is equals to 0, y will be minus 15. If I put y equals to 0, x will be 6. X will be 6. So means this point, and some point will be there minus 15. So it will come from down. It will come from down and the line will be like this. The black line. It will be like this. It will be like this. Now I need means put 0 comma 0, sir. 0 0 0 is greater than minus 30. So that means the answer will be this side. Now what is happening? You can see that the region, that means this line is having common region with your feasible solution, That means there are more x and y values where you can get more than 300, That means there is a common solution where I can get means same value like 300 also. So that means there is no minimum possible. If suppose you get something like which is never, means you get solution which is not common to both. So write as a note point like if, so two cases will be there. Case 1, if the minimum or maximum line has common region with feasible solution, then there is no minimum or maximum. Means if they has feasible means common with feasible solution, you will say there is no minimum or maximum. But if the minimum or maximum line doesn't intersect with the common region, then that point where it is making minimum or maximum will be your solution. So in simple case, sir, what you need to see is you just try for one more line of the Z. If it intersect with your common solution, you will say no solution. If it does not intersect with your common solution, you will say that is the correct value, or means that you can achieve by putting that point into it. That will be the unique point. That's it. So this one step extra we need to do if the region comes unbounded. Okay. So like this, you can see that if suppose we should have checked for this thing. So this is minus 5x plus 2y less than 10. Minus 5x plus 2y less than 10. Minus 5x plus 2y less than 10. Let's check, sir. So for x is equals to 0, y is 5. For y is equals to 0, x is minus 2. X is minus So sir, minus 2 means point will come this side and 5 is point of this side. So it will go like this. Right, sir? This Z max line will go like this, sir. Now put 0, 0. Sir, 0 is less than 10. 0 means 0, 0. 0 is less than 10. Yes, sir. So that means the region will come like this. Region will come like this. You can see that it is not intersecting your region. It is not intersecting your region. So that means this point only will be your maximum point, where it is making maximum. That point only is your maximum point, which is 0, 5. Which is 0, 5. Like this, sir. Like this. Okay. Understood? So the second case, where region comes unbounded, then you need to do one more step. Now, let's see the third part or the third case. First of all, one minimize equation is given. So that is z is equals to 3x plus 2y. Now we need to find the intersection points. Let's find out. Okay. Equation is x plus y greater than 8 and 3x plus 5y less than 15. Again in first quadrant. Sir, this is now you are already made a pro, so this is 8, 0 and this will be 0, 8. If you put 0, 0, so 0 is not less than 8. 0 is not greater than 8. So the answer will be above this side. Next, if I put x is equals to 0, y is 3. If I put y equals to 0, x will be 5. So sir, 5, 0 and 0, 3. So the equation will come like this, means they will intersect in second quadrant. Now if you put 0, 0, sir, 0 is less than 15. So that means this side. So what is happening? I need answer above this and below this. So no common area in first quadrant. There is no common area. No feasible solution. You will say no feasible solution. So if there is no feasible solution, you will write as there is no solution. There is no solution. That's it. Nothing else. Means it cannot be minimized or maximized. Understood? Under these conditions. So these are the three cases. Each case I have explained you with one example. It is more than enough, because if you solve 10 questions also, same procedure you need to do. If it is bounded, you need to put the vertex value. If it is unbounded, then you need to check that equation, that minimize or maximize equation, which you get as minimum or maximum value. If it intersect with your common region, then no solution. If it does not intersect, then it is a solution. Third case, if there is no feasible solution, no solution. Over. Only three cases. Only this much now is allowed in JEE, means what you can say board exams, in any of the board exams. So sir, this is easy part, easy plus 6 marks in your board exams. Each one of you can solve this. Each one of you can solve this. Okay. Now, this was the question I was talking about, which came in JEE 2021, 17th March, JEE 2021. Everyone thought that, okay, this is a question of what you can say, because they are asking maximum and minimum value of z, where z is 6xy plus y square. So means if I take y common, this is 6x plus y. Sir, usually it is always, so first hint which you should have got is like, sir, they have just mixed few things, that it is always a linear equation. We always have linear equation which we need to minimize or maximize, right? It is not linear. Linear constraints are given. 3x plus 4y less than 100. 4x plus 3y less than 75. Less than 75. Now, if you draw this will be the graph. I've already plotted. So this will be the graph. So we are getting this as a common solution. 0, 25, 0, 0, and means this line is giving you entire answer because this is already falling in means the region. Okay, already solved for you. So we got 3 points: 0, 0, 0, 25, 0, 0, 0, 25, and the last point is 75 by 4, comma 0. 75 by 4, comma 0. These are the 3 corner points we got. So then Z value at 0, 0, sir, it is 0. Okay. Now 0, 25, sir, 0, 25 square, 625. Now, sir, y 0, again 0. So according to this, answer is 625. According to this method, answer should be 625. So in many places you will see that answer is 625. They will say that this is the maximum value. So this is 625. But NTA have released the key as 904. NTA have released the key as 904. How this answer will become? Now, from this, sir, we came to know that 4x plus 3y is only giving us the solution. Means this line alone is giving us the solution. That line is for no use. So from here, we can do one thing like 4x, or you can say 3y is less than 75 minus 4x, or y is equals to 75 minus 4x by 3. Right? Now, put this x value. Oh, sorry, we need to put x value. So, yeah. So, 4x is less than 75 minus 3y. X is 75 minus 3y by 4. Substitute here. So, y 6 into 75 minus 3y by 4 plus y. Like this, sir. Okay. Now, if you multiply, sir, 2s are, 3s are. So, y, this will become 2y. Here it is 2. Here 3 into 75 is 225 minus 3 3s are 9y. So, finally, you will be getting something like, like 1 by 2 into 225y minus 7y square. I'll be getting this. I'm getting this. Now, if you take this as a thing like a function, z is equals to half 225y minus 7y square. So dz by dy for minima maxima. So half 225 minus 14y. Right, na sir? Now equate it to 0. So if you equate it to 0, y value will come as 225 by 14. Y value is coming. If only one value came, so at this value only it will make minimum or maximum. This will make minimum or maximum. So substitute this point here. So z will equals to half 225 into 225 by 14 minus 7 225 by what you can say 14 square, like this. So now when you solve this, you will get 904.02 or something. You can solve this at home. Okay. You can solve this at home. You will get 904.02. So the answer nearest integer will be 904. So they have used minima maxima along with one equation to get the answer. Only this was the application of LPP. Rest, these things are not used at all. Rest, these things were not used at all. So unlikely, there is no possibility that a question will come from LPP. A question will come from LPP. Okay. I hope this was clear. Okay. So that was it, guys. In LPP, you need to do only this much. You don't have to do more than this. You don't have to do more than this. Okay. I hope everything is clear. We'll see you in some other class. Till then, keep solving. PW's entire team with you. Thank you.